This is a recording of lesson 4.7, part of Math 020 Pre-Algebra course taught at St. Louis Community College. This recording is made by Dr. Victoria Shearing. In lesson 4.7, we are going to solve equations with fractions, and we have two lesson objectives. Determine if a number is a solution to an equation, and number two, solve equations with fractions. We're going to start with a review, how to determine if a number is a solution to an equation. We saw that in our previous lectures, specifically in lesson 2.3. In order to determine if a number is a solution to an equation, we're going to substitute the number for the variable in the equation. We're going to simplify the expression on both sides of the equation. And then we're going to determine whether the resulting equation is true. If the resulting statement is true, the number is a solution. If it's not true, the number is not a solution. So let's go ahead and look at our example number 1. We have an equation x minus 2 over 5 equals 1 over 10. So we're going to check if x equals 1 would be a solution to this equation. So let's go ahead and drop it in. So you will, using x equals 1, you would plug it into your equation. So you would say 1 minus 2 over 5, 2/5, equals 1/10. Okay. So finding the, so 1 could be rewritten as 1 over 1 as a fraction. Okay. So, and then finding the LCD would be 5. So we have 5 over 5 minus 2 over 5 equals 1/10. 5 minus 2 is 3, so I have 3/5 on the left, and I have 1/10 on the right. All right, I can't compare them until I find the common denominator, but I'm already seeing that they're not equal to each other. But the common denominator between 5 and 10 would be 10. So I'll have 6/10 equals 1/10, and that is false. So the answer to x equals 1 is a no. Okay. If you take 2/5 out of 1, you are not going to get 1/10. Okay. The next one is going to be x is 1/2. Okay. So let's go ahead and plug the 1/2 minus 2 over 5 equals 1/10. So the LCD between 2 and 5 equals 10. So 2 goes into 10 5 times, so that the 1/2 is going to be 5 over 10. 5 goes into 10 twice, so the new fraction 2 over 5 is the same as 4 over 10 equals 1 over 10. So 5 minus 4 is 1, so you have 1 over 10 on the left and 1 over 10 on the right. So this is true. So this is a solution. So x equals 1/2 is the solution to the equation of x minus 2 over 5 equals 1/10. The last one, negative 1/2. Okay. So similar, we're going to drop negative 1/2 instead of x. Minus 2/5 equals 1/10. Okay. We already know that LCD between 2 and 5 is 10. So the first is going to be negative 5 over 10 minus 4 over 10 equals 1 over 10. So you have negative 5 minus 4 over 10 equals 1 over 10. negative 9 over 10 equals 1 over 10. That is false. This is a no. So the answer to question if a number is a solution to the equation is yes or no, or on your assignments it would be a solution and not a solution. Again, yes or no answer. Okay. Second objective of our lesson is to solve equations with fractions. We have a couple of rules. There is no just one particular rule, but there's scenarios of what you would do in each one. So you can have one fraction that is a coefficient with a variable. So it's going to be attached to your x or y or whatever variable you have. So if your fraction is a coefficient for your variable, you multiply both sides by the reciprocal of that fraction to clear it. And then you will solve regular equation because you will get rid of the fraction. The second case, you may have multiple fractions with the same denominator. So then you would solve it like a regular equation. You're just working with fractions instead of regular numbers. In the third case, you may have multiple fractions with different denominator. In that case, you will multiply the entire equation by LCD to clear your fractions. Then solve like a regular equation. Okay, so let's see what we have. We have example 2, part A. We have two fractions, same denominator. So that means in example A, we're dealing with the second case. You have multiple fractions but the same denominator. We should solve this like a regular equation. So let's think about it. And let's imagine that we are having an equation in this form. Y plus 2 equals 5. All right. So you have a variable, you're adding a number to a variable equals to a number. So you would subtract 2 from both sides, and you would have y equals 3 using regular numbers. Now, the only difference between this example that I just wrote and the example that we're trying to solve is that our numbers are fractions. We're still going to subtract 1/3 from both sides. So that means I have to do 4 over 3 minus 1 over 3, which gives me 3 over 3, and 3 over 3 is 1. So y equals 1. That's my answer to the first one. All right. Similar situation in part B. You have a minus 5 over 8 equals negative 7 over 8. Multiple fractions, same denominator. So just like I would do with a number, I would do the opposite. Since I am subtracting the fraction, I need to add this fraction. Okay, plus 5 over 8. So let's work it out. Negative 7 over 8 plus 5 over 8. 8's on the bottom. Negative 7 plus 5 gives you negative 2 over 8. Okay. I can also reduce it. Negative 2 over 8 to negative 2 goes into 8 4 times. So I have a equals negative 1 over 4. Because negative 2 over 8 reduced is negative 1 over 4. That is your answer to the second one. All right. We have a couple of more. We have n plus 9 over 10 equals 2 over 5. So this is our third case where we have multiple fractions but different denominator. We need to multiply the entire equation by the LCD to clear the fractions. Then they will be gone, the fractions will be gone, and we will solve like a regular equation. All right, so here we are. So the LCD between 10 and 5, so by the way, just so you know, this is a 1. I can also rewrite n over 1. So don't worry about like what is like n is not a fraction. It's not a big deal. Okay. So the LCD between 10 and 5 is 10. So I'm going to multiply the entire fraction times 10. 10 times. So that means each part of the fraction needs to be multiplied by LCD. Everything. So that means I have to do 10 times n plus 9 over 10 times 10 over 1 equals 2 over 5 times 10 over 1. All right, so we have 10n this cancel each other, plus 9 equals, so this is 1, this is 2, equals 4. Subtract 9, you have 10n equals negative 5 divided by 10, n equals negative 1 over 2. All right, we have one last problem to do, part D, and you have p over negative 5 equals negative 40. So this is not even a fraction, even though it does look like a fraction. Don't even treat it like a fraction. So you have, let me see, here we go. You have a division right now. So the opposite of division is multiplication. So we need to multiply by negative 5 over 1 times negative 5, right? So these, when you multiply negative 5 by negative 5, they will cancel each other. And you will just have p left here. And negative 40 times negative 5 gives you 200. And that is your answer for this problem. 200 and the negative 1/2 for the previous one. This concludes our short lesson, a short 4.7 lesson.